To find the simplest polynomial function with the given zeros, what we need to do is recognize that with these zeros or these solutions, you can obtain a factor by simply putting x minus in front of that number. So for instance, if 1 is a solution or a zero or an x-intercept or a root, those are all the same things, that means our polynomial has to have a factor of x minus that number, so x minus 1. But there's something a little tricky with some of these values. First of all, we do have a complex number here, 2 plus I, and then we also have a square root in this problem. And there are a couple of theorems which will help us complete the problem. We are expected to know that when it comes to complex numbers, if you have a complex number that's a solution, or a zero, again, same thing, not only is that complex number a solution, but also its conjugate is a solution. So we are only told that 2 plus I is a solution, but we know, because of the complex conjugate root theorem, that its conjugate must also be a zero or a solution. What is the conjugate? Well, it's the exact same two numbers, except you change the sign in between. So a 2 minus I is also a zero, and they don't have to list it out for us because we know, based on the complex conjugate root theorem, that if we have a complex number that is a root, its conjugate is also a root. So when we list out the next factor, we want to do x minus this number. That number this time, though, is a complex number and it has two parts. So we want to do x minus that number. We do have to put the 2 plus I in parentheses, and then because of the complex conjugate root theorem, we know that 2 minus I is also a root, and therefore x minus 2 minus I is going to be a factor. There is some skill needed to go through and to identify those complex conjugates. So let me set that aside for a moment and just do some work over here just to remind you of what this might look like. So we just had 2 plus I, and the conjugate is a 2 minus I. That's really easy when you have two terms. So for instance, 6 minus 10I, if you're going to do the complex conjugate, that is a 6 plus 10I. There is an easy one that throws people sometimes, and that is, what if you only have the I term? So for instance, what if you had a negative 5I? What is the conjugate of that? Well, if you have negative 5I, you should be thinking of it as 0 minus 5I. The real term out here in front, there isn't one, so it's like a 0 minus 5I. From there, you can see pretty easily a 0 plus 5I would be the conjugate, and then we really don't need the 0 in front. We just have a positive 5I, which we would write just as 5I. So, if there are two terms, coming up with the conjugate, it's pretty easy to see. If there's a single term, just the I term, when you have a complex number, that is how you would go through and come up with the conjugate. So the conjugate of negative 5I is a positive 5I. Okay, so let's come back to where we are in this problem. We had 2 plus I, we figured out its conjugate is 2 minus I, we want x minus each one of those. Similarly, we have another square root in this problem. Remember, I is a square root. We have a real number square root. It is the square root of 3, and there is an irrational root theorem that says that if you have a radical like that, and you write it in the form a plus b square root c, then its conjugate, a minus b square root c, is also going to be a factor. So, or also be a 0 rather. So, we have x minus the square root of 3. That's going to have to be one of our factors. We need another factor here. When you have a square root, you will need a second factor. And similar to what we did just a minute ago, let me practice that a few times. If you have, again, just making up problems to talk about conjugates for a moment. If you have 7 plus 11i, sorry, we wanted to square root this time. Let me do square root of 6. 7 plus 11 times the square root of 6. The conjugate of that would be 7 minus 11 square root 6. The square root is always the last term. In this problem, we happen to have a square root of 3. There is no number in front, so we're thinking of it like 0 plus the square root of 3, and its conjugate then would be 0 minus the square root of 3, but we don't need that 0 in front. So the conjugate is a negative square root of 3. So using the irrational root theorem, we know that the negative square root of 3 is also going to be a 0, which means x minus a negative, or x plus the square root of 3, is going to be a factor. They gave us 3 zeros, but because of our complex conjugates root theorem and our irrational root theorem, we know that anything with an I in it, or anything with a square root in it, is going to have an additional root that we will need to list out. We want to put our final answer in standard form, so we need to multiply all of this out. There's a few ways of doing that. I'm just going to do this in the first step. We have some nested parentheses here, and I'm just going to get rid of the nested parentheses by distributing the subtraction in. So that's going to give me an x minus 1, and then this set of parentheses would be an x minus 2 minus I. The next set would be an x minus 2 plus I. And I'll just copy these last two down again. We have 4 multiplications here. We have 5 sets of parentheses, but multiplication is there 4 times. We can multiply in any order. I would suggest going through and multiplying anything that is conjugates together first. So in my next step, I'm not going to do this multiplication with the x minus 1 and that next set of parentheses. I'm just going to leave the x minus 1 there. But what I am going to do is I'm going to multiply these two together. So that would, using the distributive property, give me an x squared minus 2x plus xi minus 2x plus 4 minus 2i minus xi plus 2i minus I squared. And I will have my 2 sets of parentheses here again. I don't have quite enough room, so I'm not going to copy those back down. Okay, I think I got all the signs right in there. I was worried I messed one of those up, but I think I got them. Next step. What's in blue, I'm just going to combine some like terms. Here's what I see. There's only one x squared term. There's a negative 2x minus 2x. That's a minus 4x. There are some things that do cancel out. There is an xi here and a minus xi here. There is a minus 2i here and a plus 2i here. So I have x squared and then minus 4x. The only thing that's left that I haven't worked with yet is the 4 and the minus I squared. Remember that your I squared is actually not an imaginary number. So as a quick reminder here, I squared is actually equal to a negative 1. And what I have in this problem is a negative I squared. So what that represents down here is minus a negative 1. So that's going to end up being a plus 1 out on the end. And 4 plus 1 is 5. So all that stuff in blue simplifies down to just that. I do have these two sets of parentheses out here on the end, and I have room now, so I'm going to copy those back down again. All right, I did one of my multiplications. I need to do another one. I'm going to multiply this out here, and I will need to FOIL. If you FOIL that out, you end up with x squared minus the square root of 3 with times the x. I'll put the x first. So x root 3 minus then a plus x root 3, and then negative root 3 times positive root 3 is a minus 3. And if you take a look, these two terms here in the middle, they do cancel each other out. So here's where we're at in the problem. We have two more multiplications left to go. I'm going to do this one next. We do have some like terms here. One more multiplication left. Lots of distributing here. And our like terms, we have an x to the 5th. Next would come our x to the 4th term. We have one of those. Then our x cubed terms, we have a minus 3x cubed here and a plus 9 there, so that's a plus 6. Then our x squared terms, we have 15 minus 5, so that's 10 x squareds. One x term, and one constant term. So multiplying all of those out does take a bit of work. You have to be careful. I think that I was. Easy to get a sign wrong in there, easy to get a couple of terms mixed up. I would definitely focus on multiplying out these conjugates, because you end up with things that cancel pretty quickly. Same thing happened here with these conjugates. So multiply those conjugate factors together, then you'll end up with integer values pretty quickly into the problem. So if you look from here down, basically, we have all integer values, no square roots or i's left in the problem at all. You should be able to come through, and if you're careful, multiply all of that out, combine those like terms for a final answer.